Well, good afternoon, everyone. It's kind of an honor to be here and speak to you. I think I may be in between you and drinking time. But I really wanted to come here and talk about the lessons learned that we've been having at the ARM Institute. The ARM Institute is a public-private partnership in partnership with the Office of Secretary of Defense as our major funder. We spent through about a $300 million tranche, and we're working very aggressively and hard to reinvigorate, or invigorate, you could say, the U.S. industrial base through the application of robotics enhanced with artificial intelligence to really improve proficiency, efficiency, safety, and quality in the manufacturing processes. So just to really get you started, I just said we're a public-private partnership. We were the urban rumor that has it was we were, and I like to hope it's true, we were the last institute signed off by President Barack Obama the afternoon, or his last morning in office. We started in 2017 with $80 million from the DoD, $160 million additional funding from our consortium members, and then over time worked that up to about $400 million, which we spent to date. We are a consortium of about 350, 360 companies. Companies come in and leave. And how these consortiums work is we have the power to convene. We get funding, then we bring the funding to our consortium to solve difficult problems. We fund them through competitive proposals. And the proposal are in response to a technology roadmap that we've developed and an investment roadmap that we've developed, all with the focus, again, on using artificial intelligence to enhance performance in robotics. One of the things we're pretty proud of, it's actually now 68%, because as things move on, more programs transition. 68% of the programs that we funded are transitioning to be in use on factory floors, which is a huge success for the type of group that we are. We don't fund layups, we only fund needle movers. So to me, about a 60% range of what we were shooting for. So 68% says that we better take a little more risk and we fund. Again, we work in a pretty competitive space. We're the only place where Boeing, Lockheed, and Northrop Grumman can work together on a project in a pretty competitive world. And we do a lot of cross-market introductions in terms of introducing smalls, medium, and largest to their future suppliers. But just to give you an example of just what we are, so we have 50 plus industrial robotic suppliers all working together in a pretty competitive state, which you're taking a prototype that's proven to work in the lab and bringing it to a prototype that actually works in the factory floor. We don't pay for the final transition to manufacturing or low-rate initial production, but we do that pre-competitive state. We have 20 plus of the largest DoD original equipment manufacturers, 150 smalls and mediums. About 2/3 of our startups have become very successful, making it to Schedule A's, B's, and C's in rounds of funding. One of them came from 4 graduate students that are now a $25 to $30 million a year company. We have 75 plus robotics, autonomy, AI, and cobot companies in the organization. I'd like to point out that's kind of a layup for us because we are right next door to Carnegie Mellon University. Carnegie Mellon University actually wrote the proposal and set up our institute. And Carnegie Mellon University is probably one of the few places in the country where you can throw a rock down Butler Street, if anybody knows Pittsburgh where Butler Street is, and hit a roboticist in the head, and they're probably under 35. So it's kind of like Silicon Valley was when I was in my 20s. It's a really neat place with a lot of energy, all about artificial intelligence, all about robotics, and it's a great sports town as well. We have 55 community colleges, vocations, and training centers, 12 manufacturing extension programs, or MEPs if you know them that way, industry associations, and the full branches of the DoD and the government. DOC is our second largest supporter. DOC is the Department of Commerce. In terms of where we invest our money, and we do invest a lot, we invest in certain industries, aerospace, where it's really not focusing on efficiency, it's focusing more on proficiency because it's hard to manufacture things for aerospace. Maritime, which is boats, finishing hulls. Sustainment, which is re-engineered or remanufacturing defects. Automotives, composites, apparel, and footwear. Logistics facilities and warehousing. So we are literally everything in the manufacturing space, from elements of the supply chain to factories to distribution and sorting centers. We also do things for space, manufacturing in space and manufacturing on the ground to put things in space, and then now because rockets return remanufacturing for space. We did one food handling project, which was pretty cool, and we do a lot of heavy equipment. So, I'm not really here to talk too much about us, but I really came here to talk about how we've used AI to really create this new paradigm. One of the reasons we exist is manufacturing has been on steady decline in the US, actually in most industrialized nations, or formerly industrialized nations, since the 1970s. And the problem is that the modern paradigm, or the current paradigm, or even the most biblical paradigms of manufacturing is based on what we call non-living wage labor. It's the kind of job that really nobody wants. It's usually kind of dangerous, and usually you need 2 or 3 of them to make a living. And that was factory work. That's why many kids whose parents were factory workers told their kids to go to college and not become a factory worker. Part of that's a real fallacy. Some manufacturing jobs, many have to pay really well. But we realized is that if we wanted to bring manufacturing back to the United States, or bring manufacturing to any place that wanted it, we were going to have to change the paradigm and move it away and make manufacturing independent of really exploiting non-living wage labor, and make it dependent on vocational subject matter experts, i.e. people who have a weld, people who know how to sew and cut, people who know how to do the hard skills of vocational manufacturing. Back them up with mechatronics technicians, back them up with robotics technicians, and then, of course, engineers and the rest of the factory looks the same. In this model, your vocational subject matter expert teaches the robot to do the job, and then every Wednesday, everybody works in a factory, does the Gemba walk with the management team, and works on how do you make it, how do you improve cycle time, how do you improve defects, how do you improve performance, how do you improve little things that are why your line is different from the others. So those vocational subject matter experts, as they are today, remain the most important person in your factory. Our members of the Institute have been using this approach in their businesses for about the last 5 years. They believe it gives them a direct disruptive competitive advantage. We will not fund anyone that doesn't cost match us dollar for dollar. So when we fund you for $500,000, we expect you to put up $500,000 in your own independent research and development, not because we're trying to be jerks, but because that tells us that whatever you've proposed to us is on your technology development roadmap and will be used in the field. And if you get the results that you're hoping to get, it'll be used. And that's why we have such a high percentage, 68% transitioning into use. So in terms of you all using AI to do the same thing, again, you really need to push your team and look for interdepartmental leveraging other IRADs so that you're not just funding something that's cool. And the other thing we're trying to do, and I'm a pretty conservative guy from the South, so I'm from the South, a liberal from the South, as we would call a radical right-wing Republican up north. So I'm on the left spectrum down south, but up north you probably think I'm pretty right-wing. We've been trying to build what's called an environmentally just ecosystem. And for those who don't know what that means manufacturing in a way that lifts all boats in the regions where you're manufacturing, doesn't pollute, doesn't destroy the environment. And if you do it right, it actually can be rather economically beneficial. And if you have a fiduciary responsibility to shareholders, it's a great way to go. And it's actually rather environmentally just manufacturing. It's actually quite conservative, if you ask me. Thus says the liberal from the South. Anyway, so what's our view of this? Well, we have this vision of the future where we're really waging more on non-living wage on manufacturing. So we're looking at living wage or better facilities. And I'm challenged with people who say robots are stealing jobs. I always just say, I'm just confused by your whole statement. I'm not an entrepreneur, I'm an industrialist. I create new industries. Bringing back the textile industry is killing a single job in the United States because there aren't any. I'm just bringing in new industries that happen to make things that are similar to things that were made in the past. And for every job I raise on the factory floor, I have 30 jobs upstream in supply chain and 30 jobs downstream in distribution. So we're making new industries. We don't want to have factories like this little comic book one I drew here, where people stand shoulder to shoulder doing a task. We want to actually have factories where we have one really solid expert, and I'm not showing the mechatronic technicians in the background, but solid technicians, solid vocational subject matter experts who knows what that Workcells doing, knows what that line's doing, and keeps that line running 3 shifts, backed up by the mechatronics technicians to fix the equipment when it breaks down. So again, teach the robot to work. I've already talked about being there for the Gemba walk for quality and yield. And then work with it, keep Workcells running. I guess I said it earlier, it's efficiency, proficiency, consistency, yield, safety, and reduce training and reduce burden and other injuries. The other thing that we're really focused on is online tools. So for those of you who are working now, there's complete online tool sets that Siemens, Dassault, and other companies make that take you from idea to downloading the code to the robots to do the work. So it's idea, so computer-aided design, computer engineering, computer-aided manufacturing, computer-aided factory layout, tying into your ERP system, the full works, and those systems are real. We're looking at exploiting those and using those and integrating them in. So one of the things we do is we've invested and built an investment strategy. And again, we're going to talk about lessons learned. It's more important to have an investment strategy than a roadmap. If you have a roadmap, all you're going to get are the things on the roadmap. What we really want are the things that are in between the things on the roadmap, and that's what an investment strategy tells. So when we put out the calls for proposal, or if you're in a corporation, when you put out the calls for independent research and development from your team, you get what you want. We look at the cross-section of enabling technologies with needed capabilities. We've always felt that developing technologies was pretty much useless. You end up with a lot of stuff that you can't use, or you develop really cool stuff, and then you say, if only I had done it differently. So we focus on what we call the creative matrix, which really we map key technologies to needed capabilities. And it's a pretty simple thing. I could go around in a room and pretty much say, if you only had this, what would make you have a disruptive factory? And you write that down, and then we say, so what's blocking you from doing that? And we'll list a bunch of technologies. So we map capability and technology, and we put it up there. We use cross-industry workshops. That's how we come up with these. So a pretty broad team of experts. We only have people in the room that actually own steel-toed safety shoes. When I say that lightly, I mean people who actually understand what it takes to manufacture, plus folk from the academic community who know what's coming up. And very few of the other folks, because oftentimes we vote in these meetings on what's really urgent and what's important. And it's really important to have knowledgeable people voting. This isn't a political game, it's just business, and we're trying to make the right bets. So if you really want to map out what you do, and if you're trying to use artificial intelligence to enhance robots and automation for manufacturing, you need to lay out the full supply chain. And that's what we've done here. So I've kind of laid out the full supply chain from inspect, handle, and machine tech that you'd have in a supply center that's supplying your factory. And it's going to be receive, unpack raw materials, transport them around to the shelves, store, pick, place, palletize, load. We don't do ship and deliver, that's why they're green. And then you're going to bring that to the factories, and if you've ever been in a modern factory, you'll see stuff coming into the stores on one side and finished goods coming out the other. And again, it's receive, unpack, transport, store, pick, place, kit, etc. I won't read through it all. But the top line is your supply chain coming in from your suppliers. The middle is all of the capabilities that you'll have in the factory. And then the bottom line is your factory warehouse and then your distribution center. And we populate those with projects to develop the technology. We're slowly, methodically going in and putting in scan, plan, and do robotic systems to replace what I would call menial or non-living wage labor in the distribution centers and in the factories, and take those subject matter experts, maybe upskill them a little bit, and get them to be the ones that are training the robots, and then putting forth the proposals for how they're going to do manufacturing so that one person can do a whole line instead of just a work cell, and do it without getting injured, and do it without wearing a respirator. And when we're successful, we call it a very happy customer. Our goal is that you order it today, they manufacture it tomorrow, they ship it the next day, and you have it the next day. And when you look at the Pareto of costs in a manufacturing ecosystem, it's returns that's the biggest problem. Or if it's garments and textiles, it's the lag between ordering and delivery. So 78%, I do a lot in the garment industry. Like I say now, he's fashionable guy in the room who speaks at fashion conferences. The fashion industry shreds 70-some% of everything it makes because it's the wrong color, wrong size, wrong shape, etc. For the DLA, it's really hard to keep everybody in uniforms because people come in different sizes and shapes. No matter how good they plan, no matter how good your AI are, you always have plenty of uniforms, you just don't have them in the size you need. So in terms of success transitioning technology, it all begins on the plan. We stack the deck, and we require a business value proposition, a business case for everything we fund, and a transition plan, and a partner that's going to use it on the factory floor. And that's really a big deal. So it's the end-to-end ecosystem in the company that's really the most important part to know, so that your research team is designing stuff that's actually going to work on the factory floor. We like to say be the innovation engine for design and demonstration platform for the industry. That's what we're trying to do. We We think all companies should try to achieve that for themselves if they're going to be successful. Performance and affordability, so increase product performance to get affordability. And then invest in applied R&D projects, not just cool ones. And lastly, develop the next generation product and processes using this type of technology. So if you have a good process for doing this, you will transition to the field. But it all starts with the same thing. When you do your proposal for the projects that you're going to fund, you want to have a cutting-edge project that's using artificial intelligence to enhance performance, proficiency, efficiency, quality, safety, etc. in your system. It has to have a solid business case that works for your business. It has to have a solid value proposition to you, so you know that you're not just doing the layup, you're really pushing the needle. And lastly, you gotta have good metrics to understand the process that you're actually working on. And you better have a transition partner that's going to adopt that technology when it's finished, so it will get used if it actually works. And don't beat up the person simply because it didn't work. So far I'm going to talk too much about AI. But what we learned about AI is pretty interesting. So we use AI to enhance robots. The big areas that we do, and I'm heavily listed as capability than the technology. So the capability is safety and coordinated action. And then the investments that we've been putting is in human intent and prediction. So all the work you can do to predict, A, how the human will behave in a stressful situation, helps you better program the robot to be safe. And if the robot can predict how the person's going to behave in a situation, it can adapt to that person. So the robots and the cobots that are working with the person moving something heavy, the robot has to be able to predict how the person will behave while it's lifting and moving something. Because in the case of composites, the robot could be held in one end and the person holding another. And as it moves, if the robot moves it wrong, it can wrench the person's back. Lowering the training barrier to use robots, that's the capability we want. But that's really a human-robot interaction, robot-to-robot interactions where they're learning from each other. So that's really a deep learning fund. And those are things where robots can learn a task from observing a human and transfer that learning to another robot. We do a lot of this with AR, VR. So I can use a robot to weld an object in the virtual world, and that will program the robot to do it in the real world. Or for inspection, I can lay out with my hands around the object where the safe zone is so that the scan head doesn't bump into the object, so that the object can do that. That's podang kind of simplistic AI. Reduces the barrier for your employees in the work cell. Again, it makes it easier for employees to work with robots, and it makes it safer for the robots to do it. And it brings that cost down because they don't need to have, it's more important to have a vocational subject matter expert than it is to have the guy who writes Python. Dexterous, agile manufacturing, probably the most important thing to invest in right now is that dexterous control of a robot. I mean human dexterity. Part of that's mechanical, I have to have end effectors to do it, but the actual sensing and control is very important. Putting a cap on a bottle is probably one of the hardest things you can do if it's non-fixtured. It's really tough for a robot. But we're teaching robots to actually use machine learning to learn how to put the cap on the bottle. That's the simplest one. We're also doing it for inspections to say, what is a scratch and defect versus what is a scratch and how do I learn from all my inspectors when doing that? This is the other one, is inspect, is scan, plan, do. That's heavily dependent on perception, it's heavily dependent on perception, and it's heavily dependent on dexterous maneuver and control. And that is one that's really interesting in the factory because that's the one where we're starting to see things really roll out. Where we now have, you move the part up to the robot, it scans it, plans it, does it. That includes finishing, includes sand grind, chamfer, and that includes coating as well as paints and other types of coatings. And then we have low knowledge grasping, so we don't know what it's grasping, so the warehousing is really important. FedEx has cartloads of bags. They also have cartloads of just wiring harnesses that are wrapped up in a blanket. Where do you pick it up? You're going to start someplace, and then you're going to learn from how you picked it up. You may be learning from all the others you picked up. So we invest a lot in this area of both machine learning, and I wouldn't call it deep learning, because when we can put multiple lines or multiple work cells together, I can use A to train B. So another area we're done. And then idea to product, I talked about the integrated tool suites. This is like Siemens to Salt. There's lots of integrated things. It's the digital twin world, which allows me to gin it up quickly in the virtual world and develop it in the real world. And as I said, 81% of our projects choose to use AI. This is one that was really surprising to me. because we didn't require, like I said, we're the steel-toed shoes guys. We aren't AI experts, we're AI users. You asked me which AI I use, I'm doing right now. I'm looking at NVIDIA's Omniverse. I'm looking at the innovation labs from Microsoft. I'm looking at all the different tool suites, and I'm actually looking at some of the ones I saw here today. AI is becoming democratized, which is a little scary because if you don't know what you're doing, you have great confidence in making the absolute wrong decision. But with some good care and knowledge, it can be used quite powerfully. 81% of our projects chose to use it. The most common was path planning. That's the big dub. Of course, you're going to use AI for path planning on robotics. Inspection was another one, again, the big dub. You would use it to inspect, to find defects, what doesn't look right. But part of it is conforming objects to drawings. So it's inspection in 3D, conforming a part to a drawing. Or the third was taking a part that's been worn that I can't buy and replace, and making the drawing for it by inspecting multiple parts. So I don't make exact duplicates of worn parts, which is what many people do. I make it the unworn part because I've seen multiple ones. Neural network perception, classifiers, classic visioning, and I'm good on time, am I over? Over? All right, thank you so much.